Hi, I'm Anika, and this is my CA4 video on robot technology. Introduction. The objective of this video is to understand the industrial robot motions and path teaching, the robot simulation on RobotStudio, the ABB Robot Run programming using Rapid and Wizard, and the difference between simulation and real-world execution of the ABB industrial robot. This sequence is the pick-and-place program we'll be focusing on today. First, I will demonstrate the task in RobotStudio, which is an offline programming environment. After designing the 3D model of the robot cart on Inventor, I've imported it into the RobotStudio application. In RobotStudio, a virtual work cell was created to closely resemble the real ABB robot setup in the laboratory. The robot was programmed to follow this sequence. In the simulation, the robot moves to the correct positions but does not physically pick up the object, as this is a software-based verification. This allows us to check the robot reach, motion type, and collision-free paths safely before running the program on the real robot. Now, I will elaborate more on the ABB Robot Run on Rapid. The same pick-and-place task is demonstrated using the real ABB industrial robot. For this task, the pick-and-place positions were first marked physically on the work surface and taught using the teach pendant. A routine was created to perform the same sequence as the simulation, but in this case, the gripper actively picks up and releases the object into the basket. It's the rapid code from steps 1 to 19. Similarly, we'll also be running the ABB Robot Run on Wizard. This is the Wizard code from steps 1 to 19. For safety, unlike simulation, a real robot run poses collision risk that may damage equipment or cause injury to others, while simulation is completely safe. For production impact, real robot setup causes downtime and possible profit loss, whereas simulation allows programming without stopping production. For environment, real runs involve actual physics such as gravity and friction, while simulation uses idealized models that may differ slightly from real setups, such as my earlier Inventor robot cart. For accuracy, real robot operations reflects true real-world accuracy, while simulation accuracy depends on proper calibration. Lastly, for cost, real robots are costly to repair and maintain, but simulation is cheaper with no damage or downtime cost. In conclusion, RobotStudio simulation is effective for safe, offline programming and path verification. The ABB IRB 1100 demonstrates real-world execution, accounting for actual physics and constraints. Simulation helps reduce risk, cost, and production downtime before deployment. The best industry practice combines the two. It involves offline simulation for path and code verification before real robot implementation, and it is to improve the safety, efficiency, and cost effectiveness. Lastly, here is my reference slide. I hope you enjoy my video. Thank you.